Kia ora, Year 12 and 13. This is question 1 from session 11 of the scholarship calculus sessions this year, and this is a linear simultaneous equations problem with complex coefficients. Now, partly I'm YouTubing this because people who come to the Friday session will be missing class tomorrow because of Loop Day, but it's also just so that you can go over it in your own time. So pause the video and have a go at solving this algebraically. It's very similar to the easier ones that we did last week. The only difference is that we've got complex coefficients. Okay, so several ways to proceed here, but the first thing we'll do is we'll label our equations 1, 2 and 3. Now let's take a look at what's good here. Looking in equation 3, we've just got two variables. We've got an x thing and a z thing. So that suggests that I might want to use 1 and 2 together to get rid of y. The way that I'm going to do that is just how I do it with real coefficients. I'm going to try and match up these y terms, and then I'll subtract one of those changed around equations from the other. So we're going to multiply equation 1 by I. That's going to give me 2ix plus iy plus iz equals 7, and equation 2 hasn't changed. The next step is to subtract one from the other. We'll do 1 dash minus 2, and that's going to give me 2i minus 1x. I'm trying to keep it all lined up, but failing as usual. There we go, plus 0, and now be careful here, I've got plus iz minus negative iz, so that gives me 2iz, and that equals, what do we got? Well, we've screwed up, haven't we? There should be a 7i there. Okay, so that's going to give me 7i plus 1. Okay, so this is my new equation where I've managed to eliminate y. Now I'm going to work with this. We'll call this equation 4. I'm going to work with 4 and 3. I'm down to two variables, x and z, and so we're going to solve for those two first and then figure out y at the end. Okay, so equation 3, going right back to the start, was 1 plus I x minus z equals 0. And equation 4 is this. So we do the same thing again. We take a look and we try and match up something. We're going to match here. This is going to be the easiest to work with. So we need to multiply equation 3, by 2i. And that's going to give me equation 3 dash. Right, so we'll do this in lots of wee steps, of course. If you can do this faster than me, just pause the video and then forward through. Nice thing about this is I still have 0 on the right hand side. That's equation 4. This time I want to add those two together because doing that is going to mean I eliminate z. So I'm going to expand out in one step. We're going to have 2i squared, so negative 2 plus 2i minus 1 plus 2i x is equal to 1 plus 7i. Let's see what we get now. So that gives me negative 3 plus 4ix is equal to 1 plus 7i. So we should be feeling pretty happy about now because we've got our first solution coming out. So there we go. X is equal to this. All right, just a tiny bit of complex numbers. Achieve level skill. We just multiply through by the conjugate. Right, onto a new slide. So that gives me sum of two squares in the bottom. We're going to have 9 plus 16. Right, that pattern should be pretty familiar if you're watching this video. Otherwise, go do some level 3 revision. And in the top line, just expanding out carefully, we've got negative 3, minus 21i, minus 4i, and plus 28. So just be really, really careful that you don't have any problems with negative signs. It's very easy to do. I guess usually you're going to get a nice answer. So here we get a lovely answer for x. X is equal to 1 minus I. So just always check back if it doesn't work out well that you haven't mucked something up in here. So that gives me x. Now what can I do next to get z? Well, I can go back to, where am I going back to? Equation 3, which was this, 1 plus ix minus z equals 0. So we've got z is equal to 1 plus I times 1 minus I, which is equal to 2. So z is 2. And just one left to go. We'll do that on the last slide. So substituting now into, what am I going to use? Equation 1. So we can go all the way back to the start, and we had 2x plus y plus z equals 7. So substituting for x and z, I'm sure no one's listening by this point because you've all gone and finished it, but in case you are, this is what we do. Y is going to be equal to 3 plus 2i. So we can write that out nicely like this. My solutions are 1 minus I, 3 plus 2i, and 2. So there you go. Thanks for watching. I'll try and do a couple more of the questions for session 11 tonight or over the weekend.